Okay, 8.3, our SWABAT, is to factor by grouping and to factor completely. So these are the answers from your warm-up, noting that for number 1 we took out a 2m, and then from there you can box it to get this completely factored. For number 2 you can factor out -1, then you can box this, and you'll get this when it's completely factored. Don't forget to bring down whatever you factored initially. Don't forget to include that in your final answer. And then for number 3, I factored out a 5, I had b squared minus 9, and then I used a special pattern, and I got b plus 3b minus 3 times 5. Don't forget that. Okay, now for the newer portion, we are going to be factoring these polynomials, but notice these are a little different from what you've seen before because they have 1, 2, 3, 4 terms. So when it's 4 terms, we are going to use a method that's called factor by grouping. Factor by grouping. So for grouping, remember you have some popular grouping symbols. They're parentheses. So we're going to use parentheses here. And what we're going to do is we're going to group the first two together, and then we're going to group the second two terms together. So first, in looking at these first two terms that we have there, what goes in to both 2d cubed and negative 10d squared? Well, 2 goes in to 2 and 10, so I'm going to take out a 2. And then for d cubed and d squared, I can take off d squared from both of them. And then I'm going to put my leftovers in parentheses, completely ignoring this just for now. So for this one, I still would have 2d cubed divided by 2d squared. I still have a d there, minus 10d squared divided by 2d minus 5. Same process for the next set of parentheses. So 3d and 15, 3d minus 15, what do these two have in common? I'm thinking just a 3. And then I'll put my leftovers in parentheses again for this group. So 3 times what gives you 3d? Just d. Minus 15 divided by 3 is 5. And now, notice, these both have something in common. So now this is like one whole term. This is like one whole term. So what does this term have in common with this term? Well, I see a d minus 5 that they both have. And just like before, I'm going to put my leftovers in parentheses. So leftover from this term, well, I factored this out, so there's still a 2d squared. And then for this term, I factored this d minus 5 out, so there's still a plus 3. That, beautiful people, is factoring by grouping. So same thing we did for the last one. Let's try it again. So the first thing I did was to group them. So I'm going to group the first two together and then the last two together. And then looking at the first pair, what do these two terms have in common? So 2x cubed plus 3x squared. Well, there's not a number that goes into both of those, but they both have some x's. I have x cubed and x squared, so I believe I can take out x squared from both of them. And then I'll put my leftovers in parentheses again. Again, for now, you're ignoring this altogether, just focusing right here. So if I took off x squared, I still have a 2x here. Plus, I took off this x squared, so I have a plus 3 as well. Now I'm looking at the second set of parentheses. And I'm trying to think, okay, well, what do they both have in common? So negative 2x and negative 3, they only have a negative 1 in common. So I'm only going to take out a negative 1. And then I'm going to put my leftovers in parentheses. So this would be 2x plus 3. What a coincidence. They both now have a 2x plus 3 in common, and then I'm going to put my leftovers in parentheses. So I factored out from this term, 2x plus 3, what's left over? X squared. I factored out 2x plus 3, what's left over? Minus 1. That minus 1 right here. This is great, but it's also a special pattern. So this 2x plus 3 is great. It's factored as much as it can be. But that x squared minus 1, not so much. I could break that down even a little bit more. So the special pattern that I'm thinking of is a squared minus b squared is equal to a plus b times a minus b. So what squared gives you x squared? X. What squared gives you 1? So it's like x squared minus 1 squared. So x plus 1 times x minus 1, using the difference of two squares there. And that would be your final answer. Okay, go ahead and press pause if you would please and try number 5 on your own. Okay, so if you pressed pause, you grouped these two together and then these two together. These first two terms only had an x squared in common, so I took out x squared and I had x plus 1. These two had a 4 in common, so I factored that out and I had x plus 1. Then they both, looking at this term and this term, had an x plus 1 in common, so I factored that out, and left over was x squared for the first term and then 4 for this term once I factored that out. Can't do anything further with this. This is not the difference of two squares because it would have to have a subtraction sign here. So this would be your final answer. That is factoring by grouping. Now we're going to build a little bit on what we did from the warm-up problems and kind of just take this a little bit further. So even if you skipped the warm-up or weren't too sure about it, kind of going to touch base with it right now for these next 3 problems. So factor the polynomial completely. When you see the word completely, that's going to be your hint. You can do more. Don't stop. So I'm looking at these two and I'm thinking, okay, it's not squared and it's not difference of 2 squared, so that doesn't help me out. But I noticed that this is a 7 and a 63. 7 goes into both of those, so I'm going to factor out a 7. But they also have an x in common, so I'm going to factor that out as well. And I'm going to put my leftovers in parentheses. So if I took off the 7, there's no more numbers there. If I had x cubed and I took off one of the x's, I'm going to have x squared left, minus 63x divided by 7x would be 9, because 7 times 9 is 63. I took the x out right there. Now this is a special product, just like the last one. This is a squared minus b squared is equal to a plus b times a minus b. It keeps coming up. Super important. Still need you to memorize it. So that 7x is still there. And then this, because it's a difference of 2 squares, I'm going to have 2 sets of parentheses. What squared gives you x? It's going to be x and x. And then what squared gives you 9 plus 3 and minus 3. Difference of 2 squares for that one. Okay, part 7, also known as number 7. Let's look at them all. What I'd like for you to do first is to try to factor it. So they all have a 3 in common, because 3 goes into 3, 30, and 27. And then x to the 4th, x cubed, and x squared. You can take off an x squared from all of those. Let's see what's left over in our parentheses. If I took off the 3, there's no more there. I had 4 x's, x to the 4th, and I took off 2, so I still have an x squared for this one. Plus 3 goes into 30 10 times. I had x cubed, I took off 2 of them, so I just have an x left over. Plus 27x squared divided by 3x squared, well the x squareds are gone, but I still have 9 left there. So if you could please, let's continue factoring. And I would use a box for this one. So if this is my box, quickly and calmly, remember you're going to put your first term in your first box and the last term in your last box. So for multiplying, you need 2 numbers that will multiply to give you 9x squared and that will add to give you 10x. I'm thinking 9x and 1x. So to factor now, these both have an x in common, these both have a 9 in common. Then as you're looking from left to right, these have an x and these have a 1. So your final answer is going to be 3x squared, parentheses, x plus 9 from here, and then x plus 1 from there. Put a box around it. Main thing for that one is making sure that you don't forget this 3x squared that you factored out in the very, very beginning. Okay, last problem that we're going to do together. For number 8, you have negative 4s cubed t cubed plus 24s squared t squared minus 36st. Let's look at the numbers first, because otherwise all these variables can get a little bit overwhelming. What goes into negative 4, 24, and negative 36? Negative 4. Now, they all have some s's. This has s cubed, s squared, and s, so I can only take out one s from all of them. And then I can also take out, they all have a t, so I'm going to take out a t as well. And then we're going to put our leftovers in parentheses. So, if you need to, kind of helpful, you can write this out. You have negative 4 s cubed t cubed, and you're dividing that by negative 4 that you factored out here, st. So negative 4 over negative 4, that's nothing. What's s cubed divided by s? S squared, because you had 3 and you took off 1, you should just have s squared left over. T cubed divided by t, t squared, because remember you're subtracting the exponents. Now I factored out a negative, so that's going to change this sign, because a negative times a negative will get me back to this positive. So this is going to be negative, and then, okay, actually let's show you. 24 s squared t squared divided by negative 4 st. So 24 divided by negative 4 is negative 6. S squared divided by s is just an s. T squared divided by t is a t. You're basically just subtracting your exponents. Okay, and then for your last one, you have negative 36 st divided by negative 4 st. Well, these cancel out. That's nice. Negative 36 divided by negative 4 is a positive 9. This is delightful. You have a special product here, beautiful people. This is like a squared minus 2ab plus b squared equals a plus b squared. Well, what does that look like with regards to this? Well, this is like st squared, and this is like 3 squared. So that's how you can kind of match them up. So your a is st, and then your b is 3 squared. So this negative 4 st, go ahead and rewrite that because you still need it. And this should break into just a plus b squared. So that's going to be st minus, actually, this is minus, my bad, forgive me, minus 3 squared. And then don't forget, you can always use this minus 2ab to check yourself. So we're saying st times 3. Well, negative 2 times 3 is negative 6. And then that st is still there, which is the same thing that I needed it to be there. Kind of a nice one. There you go. That is factoring by grouping and factoring completely. See you next time.